Good morning and welcome to the CABE webinar Wednesday. Today we're looking at Robust Details technical briefing with Arul Amu. Using Robust Details is an accepted alternative to pre-completion sound testing when building new adjoined dwellings. This presentation will brief you on the scope of the scheme for party walls and floors, frequently asked technical questions, detailed guidance on separating floors, and an overview of how Robust Details monitor performance of the scheme standards. My name is Shanika, and I'm the Training Learning Coordinator here at CABE, and I'll be acting as moderator for this morning's session. We do strive to create interactive webinars, so we do encourage you to submit any questions you may have during the session. These questions will be addressed at the end of the presentation, and we'll get through as many as possible. If we do run out of time, we'll collect any questions and send out the answers out in due course, and you can also contact us on webinars@cbuilde.com. If you're watching us live today, you can use the side panel to send in your questions. Alternatively, you can get in touch with us via the social links now on screen. So let me introduce today's webinar speaker. Arul is a technical coordinator at Robust Details Ltd. He's been involved in building industry since 2018, originally starting with the shop fit out industry, specialising in installation and project coordination on various number of projects around the country, before transitioning over to design and technical with the housing development sector, playing a pivotal role in design and technical authorisation to achieve project goals. He joined Robust Details Ltd in May 2023, where he's now part of the technical team and is responsible for the monitoring of the details. I just want to make you aware that Robust Details have provided an e-learning available to CABE members. The modules cover the basics of sound and building acoustics measurement, and they also explain how different material properties contribute to sound insulation and how to avoid costly errors on site. If you'd like more information on this, please get in touch at webinars@cbuilde.com. If you are a CABE member, you can find it on our website. So if you give me a moment, I'll just hand over to Arul and he will begin shortly. So I'll stop sharing and you'll be able to share your screen. That's that. I can see your screen.
Instead, and I work for Robust Detail as a technical coordinator. Today will just be kind of letting you know what Robust Detail is and how the scheme works. So any questions at the end, please feel free to ask, and hopefully I can answer them. So the agenda will be an introduction of the scheme overview, as I said, understanding registrations, separation of common parts of flats, common queries, the lowdown on floors, timber floors and fire, which is a big thing nowadays, services and floors, and how the performance monitoring works from a Robust Details point of view. And obviously I'll give you an opportunity to kind of ask questions and what kind of feedback we get, and then we'll conclude there. So what are Robust Details? The Robust Details scheme standards are based around an average performance improvement of 5 dB of the minimum building regulations, compliance standards recommended in approved document E, by testing an as-built system for conformance and conducting ongoing performance monitoring. Robust Details are able to offer an alternative to pre-completion sound testing regime. So the scheme can be used for newly built or joined dwellings and flats only. It cannot be used to evidence compliance for conversions or extensions, and also not for student accommodation or care homes, unless they are categorized as flats in the building control purpose group assignment, commonly found in approved document B for fire safety. It obviously covers Part E in England and Wales, but the same scheme can be used in Northern Ireland, as they have the same performance standards. There's a separate scheme for Scotland, as they have different performance standards. To give an idea, there are 69 details for England and Wales, and only 13 for Scotland. This is a complementary service, so building control still needs to go to site to undertake the checks, and they would for any other aspect. We do go to site from Robust Detail, but this is only to check that the details are performing as the scheme remains fit for purpose. While on site, we can do a bit of knowledge transfer, so we can tell the builder what he needs to do to comply with the detail, but we are not licensed or authorized to check for building regulations. It is still very much so the job of the building control to check compliance. And by that, I mean the plots have been registered and the construction meets the specification. So the person using the scheme needs to select an appropriate robust detail, ensuring that all specifications can be met and include these in the design drawings. Then they need to register the plots with robust details and use the registration documents to notify building control before any work start on site. And finally, ensure that on site the construction is in accordance with the robust detail specification, which is very important. Robust detail registrations can only be made to separating elements between residential units. In housing, this is typically and simply confined to walls. In flats, this includes both separating floors and walls. So here we have an example. In a block of flats, we can expect to find other separating elements, which also need to perform in respect to the passage of sound, such as floors and walls between communal areas and the flats. These cannot be registered, but may sensibly be built following the robust detail specification to ensure we provide reasonable resistance to the passage of sound and also meet the flanking requirements at junctions with registered separating elements. This diagram shows in orange those walls and floors subject to requirement E1 that can be built as a robust detail. Those in blue are walls to which the requirements apply. These could be built to a robust detail specification, but not registered. In this example, we also show walls in pink that are not compliant with the scheme standards due to their flanking conditions with separating floors. Plots 7 and 8, as you can see, have walls that terminate at the underside of the separating floor, so it cannot be registered and instead should be subject to testing. The same principle applies to plots 11 and 12, where the wall is built off a separating floor. The next slide explains this in more detail. As we just saw, a dissimilar layout between floor levels can cause situations where registrations to use the scheme standards is not possible. Separating walls with a continuous floor above are a good example of this. Here we have a top floor penthouse with a separating wall underneath. A floor which is continuous over a separating wall connects two leaves together. The floors can be registered with robust details, but you need to make sure the planks are tightly butted together and fully grouted. By making our floor compliant and continuous above, we have, however, connected the leaves of our lower separating wall, introducing a flanking sound pathway around the wall. This wall cannot be registered and therefore needs independent acoustic design advice and testing. So moving on to separation of common parts of flats. So there's a few misconceptions with communal spaces, which we'll talk about now. We mentioned earlier that separating walls between communal spaces and flats must meet a reasonable performance for resistance to sound, but cannot be registered with the scheme. The same principle applies to floors over the communal spaces. Building a robust detail floor means meeting the flanking conditions at the abutment with walls, whilst also performing for sound resistance. Typically, we will need provision to limit reverberation in the common parts where this is applied to the ceilings. It should be in a metal frame grid mounted below the robust detail separating floor and not in a substitute of any of the required ceiling treatments. If a non-robust detail wall is used, it is imperative that the blockwork used meets the flanking requirements of the separating wall floors. The example here shows that flat 3 extends above the communal area, therefore the entire floor needs to match the specification. As the separating floor has provided a natural break and protects from flanking sound, it would be possible to change to another wall type above the separating floor if desired. Separating walls must be consistent between separating floors, but may change at these junctions, subject to compatibility, being identified in Table 3A in the Robust Details Handbook. Right, at the beginning, we looked at the overall scope of the scheme and where it applies. Now let's look at some specific situations with common queries we receive in relation to these. So mixed-use buildings. Requirement E1 says we need to protect against noise from adjoined dwellings and any other parts of the building, which would include the shops below. As we said earlier, robust details are for dwellings, dwelling separation, so the podium deck between flats and shops would be covered. You could then test this, but the shops are open plan. The difference in sizes could make this difficult if the noise from the shops is expected to be the same as from the dwellings, and the floor is built as if it was a robust detail. Building control could consider this as evidence of compliance. Then we need to ensure that any walls built off the podium deck meet the robust detail requirements. Build a masonry robust detail separating wall off an in situ cast podium slab. We need to isolate the wall from the slab to prevent flanking sound transmissions. Appendix A2 in the handbook deals with the specific flanking conditions and includes a detail for using this local pool monofloor bridge stop system. This consists of an isolating membrane between the slab and the wall and an acoustic quilt up one leaf of the wall for 2 lifts to mitigate against any debris forming an acoustic bridge across the wall. Moving on to fog units. This is a situation where there is a flat over garage that are different in ownership, so the floor is a separating floor. However, Part E doesn't mention garages, so building control bodies have to decide whether it's an external space or another part of the building where E1 will apply. Because registrations are only applicable between dwelling plots, for a floor to be registered between a dwelling and the garage would need to be demised to an identifiable plot registered with the scheme. In most situations, it would be likely that requirement E1 would be deemed applicable. Keep in mind that to build a robust detail separating floor, the floating floor treatments and ceiling treatments specified must be installed. It is very difficult to conduct a sound test between garage and the flat above. So if an alternative to a robust detail is proposed, the method of evidencing compliance to building control will require individual consideration. Integral garages. If a wall is registered with robust details, as far as we are concerned, the whole wall has to meet the specification. With integral garages, there is a temptation to leave the finishes off, especially where gypsum board is required. If this is done, the wall will not be considered a robust detail in that area. The designer and contractor will need to demonstrate that they have made reasonable provision to the passage of sound, again, accepting that this is very difficult to conduct a meaningful test through a garage wall, of course. Building control may consider that the full extent of the wall should reasonably perform to the passage of sound, and if so, the full surface finishes must be applied. In a similar way, the whole floor has to be built to the specification where level entry showers are fitted. The required finished floor treatment will be lost, and this can include large amounts of screed or flooring being missed. As bathrooms are so small, it's just about impossible to test to see the effect of performance. So again, both the designer and building control body need to make a reasonable judgment on compliance, balancing competing needs of Part M and Part E. Where bathrooms are stacked in a vertical alignment, this negligibly effects on performance may be easier to justify. Lowdown on floors. During past seminars, we focused on floors for good reasons. When they fail very badly. Screed isolation is such a key factor, but it's worth thinking about the construction build sequence in relation to non-load bearing internal partitions to ensure workmanship errors don't get formed. Our top tip explains the internal walls can be installed on either the precast concrete floor or on top of the finished screed, or a combination of both. What differs here is where you install the screed isolation. Whichever way, think about the detailing at the internal doorways. Perimeter isolation by the flanking strip should extend into the internal doorways, entrance, door thresholds, and to any balcony doors. Here we have an example of how it would be suitable to finish the screed isolation within an entrance threshold. You will note there is no isolation within the communal floor, as when it is not above an apartment, it does not have to protect against impact noises. This means the screed can be directly applied to the concrete planks. It's good practice to prevent this impact noise tracking sideways into the apartment. So think about the type of cavity stops used between the corridor and the apartment. Also, if a door threshold strip is used, this should sit on top of the flanking edge strip. As you can see there in the diagram. Height windows or Juliet balconies are often detailed incorrectly, and as in this example, the resilient layer and flanking strip is left out. It's important to treat these areas as you would do for the remainder of the external walls. This means you extend the screed isolation into the reveals as seen here. On to walk-on balconies. Walk-on balconies can cause issues that there are two construction methods you could adopt. You could extend the floor into the balcony area if this is above another flat, or you could build the external walls of steels as seen in Appendix A1. Noting this provides for a boxing treatment with 2 layers of gypsum board and 50 mil of mineral wool. It is important to stress that steel beams can only be used in this way to support the flanking wall construction and never be separating masonry wall between dwellings. Once we have everything in place, don't fall at the last hurdle and not complete the final stages of the floor specification. The flanking strip we left up the wall earlier is now ready to receive the skirting board. Both the skirting board and gypsum boards must not come into contact with the screed. So to do this, the flanking strip we dressed up the wall and over the edge of the screed gets folded down, ready to be cut back to skirting and sealed with a flexible sealant. Moving on to timber floors and fire. As Part E's scheme, we only get to see and access acoustic data, but this doesn't stop people ringing us on a regular basis to ask if Robust Details achieves 60 minutes fire resistance, because materials in the floor buildup can come up from multiple sources. It was difficult for any of the suppliers to commit to fire performance when they have no control over all of the components. So it's been difficult to obtain the required data, as you can imagine. Recognizing this, the SDA has published guidance on how to construct for fire safety, and within this is how to demonstrate 60 minutes for separating floors. Guidance covers timber eye joists and metal web joists, which of course looks like our EFT1 and EFT3. But if we look at the SDA and Robust Details specs side by side, we can see they don't immediately line up. So does this mean that you can't meet both requirements without having to conduct some sort of test? No, not at all. If you select the components in the orange cells, these will meet the minimum specifications for both and will enable you to demonstrate compliance with Part B and Part E. One bit that's possibly worth pointing out is that the SDA spec does not allow any recessed lighting in the main ceiling, whereas the Robust Detail does. However, a second ceiling can be introduced, which can be cut for the lights, and this will again meet both parts. Also, as we can see, both allow SVP penetrations. We just need to ensure this is done correctly. Incorporating the requisite services in floors requires detailed consideration to ensure these do not compromise performance. Starting with SVP penetrations, The point of the treatment is to protect the hole in the floor. Noise breakout from the pipe is environmental. For those who work with floating screed floors, you will know the importance of isolating the screed from surrounding structures. They account for about 65% failures. When it comes to SVPs or waste pipes, the same rules apply. So we can see here that the screed is only touching the squishy stuff, so impact noise will not transfer. And of course, the same goes for floating floor treatments. Here are a couple examples of incorrect SVP installation. Penetrations and ducting in concrete floors. Cabled services are generally not an issue. However, pipes or ducts need attention. If any drop below the ceiling, they will need to be boxed in with the same specification of ceiling board as provided for on the ceilings. Ventilation fans and their ducts must not connect the ceiling to the floor structure to maintain the acoustic integrity of the separating floor. The noise of fans in operation is environmental and is not provided within the building regulations. Recessed downlighters can be installed in the ceiling at a density no greater than per 2 meters cubed of ceiling area and at a spacing no less than 0.75 meters. Openings in the ceilings may be a maximum of 100 mil times 100 mil for this purpose. However, keep in mind the need to also demonstrate no detriment to the fire resistance of the floor. There are alternative options for compliance, include the use of a second ceiling or for manufacturers to conduct testing on the light fittings, intended in accordance with Appendix F, which is also in the handbook. Steel and timber floors, as we can see here, we need to have a blocking between the joists to prevent flanking noise, transferring between the external cavity and joist zone. When installing extract fans, the natural method would be like this, but as you can see, this will compromise the blocking. Also, as the ducting bridges the resilient bars, it can also compromise their performance. So the first option could be to use a second ceiling. This will alleviate both of these issues. Unlike those in concrete floors, any recessed lighting in timber separating floors must have been subject to testing in accordance with Appendix F. And the size and spacings of limitations of 100 mil square of diameter and density of 1 per 2 square meters with 750 mil spacings is absolute. Services can run in the batten zone, and if the services need to go across the line of the battens, a gap of up to 50 mil is permitted in battens. So we said at the beginning that both building control and robust details can check the details on site. So let's start with the building control's responsibilities. Annex E at the end of ADE explains how the scheme fits in the building regulations and identifies the responsibilities. We mentioned earlier that builders need to notify building control before work starts on site. This is so the whole construction can be inspected. If notification is late, the building control body won't necessarily know what has been constructed, so they can ask for a test to prove the performance. If building control body is confident that what has been built meets the robust detail specification, they could accept the late registration. If the construction does not match the robust detail specification, then the building control body can ask for a test, or if there's only minor deviation, they could ask for the remediation to bring it back to the spec. If this cannot be done, building control satisfaction, they could reasonably ask for all separating elements to be tested. Although we also visit site, this is to randomly sample registered plots, check that the details are performing as they should, and the scheme remains fit for purpose. We are not there to sign off for building regulations. To do this, we have independent consultants who do the monitoring for us, and this comprises of 1% of registrations being subject to a visual inspection and report, and 2% of registrations being subject to a sound test at completion. So this is considerably less than the 10% recommended for pre-completion sound testing, and is performed predominantly for ensuring the scheme standards are performing as expected. Very occasionally, we will test a structure that doesn't meet building regulations minimum performance. When this happens, we will offer to conduct an investigation to try and determine the cause of the failure. Then even though we're not checking for compliance, if we do see this, we are obligated to notify the builder and building control. This is done by sending what we would call a red letter to the builder and BCB, and this identifies exactly where the failures occurred, as well as the probable cause. It is then for building control to decide what they want from the builder. As already discussed in Annex E, this could result in an increased regime of pre-completion sound testing on the project. The same thing happens if we see work in progress that is likely to underperform. In this instance, the cavity in the timber frame is only 40 mil instead of the minimum 50 mil. When we have tested walls similar to this before, there's been a characteristic dip at 125 Hertz due to the induced panel resonance. As this is at the low frequency end, it will affect the DNTW and the CTR calculations. So it's very likely to fail if it was to be completed and tested. So in the same way as the testing, we would draft a red letter and send it to the builder and building control. Then the building control body can decide if they would be satisfied with remediation or if the sound testing would be required, all following the guidelines of Annex E. As I said, these sorts of issues are very few and far between. To put this into some sort of context, we've now sound tested around 31,000 dwellings, and the levels of compliance achieved by the industry are very encouraging, as you can see. In green, we have 98.5%, meeting or exceeding robust detail standards. In amber, we have 1.1%, that meets or exceeds building regulations minimum performance. And in red, we only have 0.4%, failing to meet building regulation. So 99.6% compliance overall. Understanding the causes behind the ambers and particularly the reds is the key to helping further improvement. So that's how well the scheme does in terms of building control compliance, but what have the results from homeowners been? The builder is ultimately responsible for building a house that complies with regulation and it's fit to be lived in. So that should be the homeowner's first contact. In 2022, the number of noise concerns equated to 0.02% of registrations for the period, with less than half of those being identified as airborne issues. It is important to use the performance data to establish or have any improvement and to understand what is happening on sites. You can see here that the floors are more likely to fail than walls, and walls typically fail through cavity bridging. Breaking down the instances of failure in separating floors, we can again see the scheme shows impact noise is the main culprit. This data we use to target our efforts on improving understanding across the industry. Correct isolation of floating screeds is key to continuous improvement, so please forgive us if we keep laboring this point at every given opportunity. So this concludes the technical bit, but it's always good to explain how we ensure the robust details patterns perform. Edinburgh and Napier University completed the occupier survey to capture homeowners' opinions, and the results are clear. At 45 dB, which airborne sounds is set as minimum, over 80% of homeowners said in their opinion the performance level were very poor and unsatisfactory. But by adding just 3 to 5 dB to the airborne rate, returns at 70 to 100% performance as good or satisfactory. We just want to point out this was pre-COVID, whereby working from home was at a reduced rate to today's trends. So we often get asked how to increase the performance of robust detail patterns now. So a final reminder, if you're using the scheme, the key is to register before work starts on site and make sure the details selected are compatible with your development. You must build strictly in accordance with those details. So make sure there are no conflicting specifications on drawings or unplanned product substitutions. Designers and contractors need to be able to evidence to building control that they have complied with required E1 by registering the plots and building to the correct details. Ensure the site teams are fully aware of the details and the checklist for compliance with those details. In promoting best practice, our main source of information is the comprehensive Robust Details Handbook. You can also find a wealth of information on our website with animations, top tips, and newsletters. Suppliers with certain specified registrations will attend site and delivery toolbox training as a condition of their registration to ensure the site team know how to deploy the details correctly. Finally, if you have any other registrations or technical questions, please do reach out to us at the telephone number or email address shown here. Thank you for listening. I hope this was useful.
Thank you. That was great. So this is your opportunity, guys, to add in your questions so you can answer them live. We do have Neil Bodsworth. He said, regarding recessed lights and ceilings, would larger downlighters, say 115 millimeters dia, be allowed if they are wider spaced?
Yes, they would. Yeah,
they would. Okay.
They would be. Yeah, they would be. So, as I said, in regards to downlighters and spacings, we do have the exact information you need within the handbook. So if you have a look at the handbook by downloading it on the website, you'll have all the information you need required for that.
Okay. Any more questions, anybody? This is the time to ask them, otherwise I can send them a bit later. Zim here, would you be able to send the presentation across? It is very useful to know. Very useful to
no problem. No problem at all.
Okay, yeah, it's fine. Okay, so we don't seem to have any more questions. It may come a bit later. This just wanted to make you guys aware that this presentation was recorded and will be uploaded to our YouTube channel in due course. This can be shared with your colleagues. I think it'll be very useful. And with that, I'll wrap up, and hopefully I'll see you guys next month.